All right, what we're looking at today is how to manipulate the numbers that have to do with protons, neutrons, electrons, and the isotopes, and the charges, and all that kind of stuff. So what I have is a chart here that you're going to be using, and at the bottom of this chart, which you will find a link for in tonight's homework page, that's this chart right here. Okay, I copied the bottom two lines and blacked out the or whited out the symbols. And one of the things that we might do right now is you can turn off your recording and record and make sure you can read the things that I've written in green. That is green, isn't it? Yeah, green ink here. So let's stop the recording. So where do I get the 7 from? This 7 right here. Where'd that come from? Well, that's true, but where do I find the atomic number? Where is that? Okay, above the symbol in the periodic chart. So if we look at nitrogen here on the periodic chart, you see a 7 there at the top. And down at the bottom, you see 14.007, yes? Okay, so that's 17, or the 14.007, and let's get in there nice and close. Aha, now we can see it better. There we go. Nitrogen 7, that's the atomic number. And then down here, we have the atomic mass, which is very different than the mass number. Okay, and we'll talk about how that works in just a moment. And so you can see over here for oxygen, the atomic number is 8, and the atomic mass is 15.999. Now, how do I get the mass number for nitrogen? It's 14.007. So when I make this a whole number, rounded whole number, what is it going to be? 14. What will this guy be? 16, exactly. So that's what I wanted you to see in the periodic chart. That's where you're getting. So as we go to fill this in, we're going to see that this 7 here is not really the mass number. The mass number comes from this guy right here, the atomic mass. So we are going to write in over here 14. Now, where do the protons come from? How do we get protons? The atomic number, yes. Okay, so protons are 7. And neutrons, how are we going to get neutrons? No, they're not the same as the protons. In this particular atom, yes, but that's not the way we get the number. Okay, protons get subtracted from the mass number. So it does happen to be the same number for nitrogen. So, and now what about the electrons? Same number as, now we go back to the atomic number. And notice that nitrogen has no charge up here, so we need to just leave that as exactly the same number. So that's basically what you're doing. Now, when you do not see the numbers around the symbol, and what am I talking about there? Let's look at this guy. See up here? There's numbers around the symbol. Would you all please be looking at that right now? This is something you want to get a good understanding of. This is the charge. It has to do with the number of electrons, not anything to do with the number of protons, except that we're going to have neutrons and protons equal the same in our neutral atoms, and then we're going to adjust our electrons to get this number, because you can't change the number of protons. For instance, nitrogen is number 7, right? Let's go back to the other page. Don't we have nitrogen? Number 7. Okay, what if we added a proton? Then what atom would we have? Okay, if we have 7 protons for nitrogen, How many would we have if we added one more proton? 8. Okay, who's number 8? Okay, that's what happens if you change your protons. You get a different element. Okay, so you can't mess with protons. At least not with chemical equations. With nuclear equations, yes, but not with these guys. Now, the other numbers that we need to figure out are, how do we get this guy? What is it? Where's this come from? Huh? No. Well, it is the number of protons, but it's the atomic number on the chart, which is the number of protons. Yes. Okay, so that number is going to go right here. Now, what's the number in the top left? Huh? Come on, what is it? Mass number. Yes. Okay, so mass number is 14. And now we're done. I'm going to let you know that this guy is forming a 3- ion. Let's see what that means. We're going to go to nitrogen. So let's put nitrogen up here. How many protons does nitrogen have? 7. Okay, so we're going to pull those guys in. 1, 2, 3, 4, 5, 6, 7. What's our total positive charge? 7 plus, right? Okay, let's go to the electrons. How many electrons did we say nitrogen had? Not the ion, but nitrogen, the atom. This is 7. Okay, here we go. 4, 5, 6, and 7. So what's our total negative charge? 7 minus. Okay, and so the net charge is equal to 0. Okay. So now we get a net 0. So all we're doing is adding the protons to the electrons, substituting their charges as the number. Okay? So each of these little guys has a 1 minus, each of these little guys has a 1 plus. Now we're going to change to nitrogen, the ion. Are we getting the idea here of what's going on? What do I have to do to get a net charge that is equal to a 3 minus? Huh? How am I going to do that? Do I add electrons or take them away? Take them away, huh? Oh, you want to see that? Okay, here we go. 1, 2, 3. Is that what I should take? Huh? Is that what I should take? Okay. So I've got 4 minuses here now, right? Isn't that the number? 4 minus? And yeah, that's not a 3 positive. I mean a 3 negative. It is a 3 positive. So what in the world am I going to do? Oops. I shouldn't have done that for sure. Okay, here we go. Let's get rid of this guy. And so to get my totals right, I've got to bring in 1, 2. I'm going to put back the 3 that I just took out. And how many more do I need? 3. Okay, so how many total negative charges do I have now? Huh? 10, right? 7 plus 3. So this is 10 negatives. So 10 negatives and 7 pluses, we get 3 minuses. Are we good with that? Does that make sense? Okay, let's go back up here now and let's put the numbers in. What is the atomic number going to be for nitrogen, the ion? It's still 7 because you can't change the number of protons. So We got 7 for the atomic number. And what's the number up on top here going to be? Huh? What's it going to be? Is it going to change? Isn't that the mass number? So what's the mass number now? 14 still. Here we go. So 7. And what's the atomic mass going to be now? 14. And now what's the mass number? 14. So we have 14 again. And how about protons? Did they change? Okay. Neutrons, did they change? No, neutrons don't. Neutrons do not change unless you have an isotope, which you'll be reading about in your text this weekend. Okay? How about electrons? Did they change? Oh, yeah. What's the new number of electrons? Huh? 10. Okay, now let's take a dude that goes positive. Beryllium forms a 2+ ion. But we're going to do him first of all as beryllium the atom. So, what's the atomic number for beryllium the atom? Anybody there? One person? Anybody else? I think I'll just call you by the cards. Okay, so that way we give you a chance to get involved. Arnab. Okay? Well, his name was on top. Okay, Arnab, what do you say? What's the number in the bottom left for beryllium? 4. Absolutely. That is going to be the same for both of these guys, because that won't change. Okay, both of them will have a 4. And let's go to someone else. Miriam, how about it? What are we going to have for beryllium, the atom, when we get a mass number? Okay, well, I've got the mass there already. 9, very good. Okay, so a mass number is 9 because we're going to round that 9.012 to the nearest whole number. Okay, so Daniel, you're on. And what do we want for protons? 4. 4 because 4 is the number here for the atomic number. Right? All right, so let's get rid of that. And now what else? We got to have the number in the top left. What's that going to be? 9. Sure. Okay, that's our mass number. And now how about neutrons? 9 minus 4. 5. And what do we have for electrons? 4. Because there's no charge. Okay? Now, how about in beryllium the ion? Mary, what do you say? What's the number in the top left going to be for this form of beryllium? Okay, so instead of the 9 like we have for beryllium up here, by taking away 2 electrons, we're going to change the mass by 5. Okay, Mary, an electron is 1/2000th of a proton. Is the electron going to make any difference in the mass? Huh? No. course not. So that's going to be a 9 up there. All right. Now, Samantha, how about it? What are we going to have for our atomic number? Huh? So the atomic number is 4 because it's beryllium, and we put that there. And what do you think, Samantha? What's the atomic mass going to wind up being? 9? Yeah, good. Okay, and what would the mass number be? Very good. You're rounding perfectly. All right, let's give someone else a chance. Melanie, what do you say for the protons? Huh? What do you say for the number of protons? Uh-huh. Neutrons? 5, yes. Okay, and the last and probably most important number, Anna, what are we going to have for electrons? This is a 2 plus ion, yes. Huh? Okay, let's test it out. Let's go down here and look at what happens for beryllium. Let's get nitrogen out of the way, get beryllium in here, and this guy's going to be a 2 plus. So let's put a little 2 plus up here. I hope we're going to get a 2 plus up here. There we go. Okay, so this guy's a 2 plus. If he's a 2 plus, let's get rid of, let's make him the right numbers here. There, get rid of those guys. And whoops, one too many gone. There we go. Here's the guy without being a ion. So we have 4 pluses and 4 minuses, and that makes him neutral. So now what are we going to do to make him a 2 plus? You wanted to add 2 electrons? Ah, okay. So you're going to take 2 electrons away. Doesn't this help? A visual really helps, doesn't it? Okay, and now what do we have for our total plus? Total pluses? Protons, yes. Okay, good. And what do we have for our total minuses now? 2 minus, indeed. And that is going to tell us that we have how many net? Huh? 2 plus or minus? Yes, indeed. Good. So we had a 4 plus here, and come on. We had a 4 plus that we added to a 2 minus, and we come up with 2 plus, and that is the charge on our ion, and that's the way it has to happen. So as we go back here, we know the number here now, don't we? Yeah, good. And that's how we do it, folks. Let's go over and look quickly at hydrogen. Hydrogen is a little bit of a fooler. Yes, Michael?
So are you always subtracting from the electrons in environments like a minus charge or a plus charge?
Okay, what did we do with nitrogen? Had to add electrons. Because we have now 3 more electrons in nitrogen than we have in nitrogen, the ion, than we had in nitrogen, the atom.
If the charge is negative, you always add electrons?
You add electrons, yes, it's opposite.
Oh, okay.
Yes, and so all you can do is change electrons. You cannot change protons, because that, not unless we have an isotope. That's what you're going to learn about in the book over the weekend. Just that one thing. That's all you got to learn about. Okay, are we good? Okay, what we just did as a class was figured out the numbers for hydrogen. And as you can see here, again, yeah. Okay, so for hydrogen, the atom, it was atomic number 1, and for hydrogen, the ion, it's atomic number 1. Atomic mass does not change. The mass number doesn't change. The protons don't change, nor do the neutrons. What is going to change is the electrons. To get that 1 plus charge there, that's the only way to do it. Okay? So as you look down here and you see these different atoms, please be sure that you fill these numbers in. So what's the top number and bottom number going to be for hydrogen? Huh? What are these two numbers going to be? 1 and 1. Yeah. That'll be the same for both the atom and the ion. And down here they've got the numbers. Oh, would someone look up uranium? What's the bottom number for uranium? Save it.